Hello viewers, welcome to this session tonight. It's Obonyo Kenneth on the e-learning project, Google the TV. Remember, e-learning is here to assist you through this session of mathematics. Tonight we are going to be having some bit of revision in mathematics O-level, so please get ready. Get your calculators, get your books, get your pens, and load enough yaka. And make sure you have washed your hands with soap. So, on the blackboard, we are having a simple question. They are saying the figure below shows a right-angled triangle. They want us to use it to determine the value of x. They want us also to use it to find the area of that very triangle. But remember, this is the shape that we are calling a triangle. It has three sides. The first side, which we call the height, is x plus 7. But remember, the units are centimeters. The second side is x centimeters. And then the longest side, which is the hypotenuse, is 13 centimeters. So they want us to use it to find the value of x and then the area of the triangle. So without wasting much time, remember this is a mathematical question. The examiner has put us to a task. But Mr. Examiner, sir, in our solution, this is very simple. You want us to find the value of x. But what we know is this is a right-angled triangle. And since it's a right-angled triangle, we need to ensure that we first get the length. That is the values of x. But how do we get them? Remember, in some few years back, we used to talk about the Pythagoras theorem. Now, I know some people might not be remembering that. We call that the Pythagoras theorem. And remember, in the Pythagoras theorem, it used to state that a squared plus b squared is equivalent to c squared. And that is exactly what we are going to use tonight in solving for the value of x. Now, Mr. Examiner, sir, from a squared plus b squared equaling to c squared, we need to know that this is our a, this is our b, and that is our c. But remember, we have to substitute. Where there is a, we are going to fix there the x plus 7, which is in centimeters. Where there is a b, we shall fix there the x, which is also in centimeters. And where there is a c, we shall fix there the 13 centimeters. Now, what is our a? Remember, it is x plus 7, which is squared, plus our b, which we have said is our x, which is a squared, which would equal to a c squared. But our c is the longest side of the triangle, which is the hypotenuse, which is the 13, but the 13 is squared. Good. So we shall have a 13 squared there. But I know some of you have a problem when it comes to the expansion of x plus 7. When I talk about expansion, I'm looking at opening the brackets. We can go for side work. Now, if we have our side work here, x plus 7, which is squared, this simply means that the x plus 7, which is squared, that bracket must be multiplied by itself because it is squared. Remember when I said 2 squared, I mean 2 times 2. Now, Mr. Examiner, sir, this will equal to x plus 7, and then again x plus 7. Because they are saying it is to the power 2. It is twice. So, we shall have the opening of our bracket, the first value, the x, into multiplied by the second bracket, which is an x plus 7. And then after removing the x, we are now left with a positive 7. So we also bring on board the positive 7, multiplied by the same second bracket, which is x plus 7. Wonderful. Now, we need to multiply. X times x. Someone is telling me 2x. No! X times x is not 2x. No, someone again is saying x plus 1. No, it is not x plus 1. We are multiplying x by x to give. Very good. Someone has told us the right answer. It is x squared. Wonderful. So we come and write the x squared there. Then plus, now we are having x times 7, which gives us a 7x. So we have 7x there. Remember, we are expanding. We are expanding this bracket here. X plus 7, which is squared. Then the answer we shall get there, we shall copy it, come and paste it there. We come and place it there. We simplify so as to be able to get the value of x. Now, back to the expansion. We are now having a 7 times x, which will still give us a positive 7x. Plus 7 times 7. Someone is telling me 14. It is not 7 plus 7. It is 7 times 7. Now, 7 times 7 gives us a 49. So we are going to write our 49 there. That is good. Now, what do we get later on? We have our x squared plus, now we are having two common factors here. A 7x and a 7x. They come from the same family. We are going to add a 7x plus another 7x. What do you get as the answer? Someone is telling me 15x. No, it cannot be 15x. It is 7x plus 7x. Someone again is telling me 49. It is not a 49. 7x, we are adding on another 7x. Very good. To give us a 14x. So we write our 14x there. And then plus our 49. That is our expansion. The expansion of x plus 7, which was squared. Now we are going to pick this answer here. We come and paste it here because it was the expansion for x plus 7 squared. Very good. Now, without wasting time, Mr. Examiner Sir, we are going to come and write our x squared plus a 14x plus a 49, then plus our x squared. So we have x squared there, which would equal to, now we are having a 13 squared. Remember, it is squared. Someone is telling me 16. No, it is not 13 plus 13, which gives you it is not even 16. 13 plus 13 should have given you a 26. But they are saying a 13 squared, which is a 13 times a 13. Yes, who can give us the answer? Yes? Wonderful. It is 169. Please, if you're not sure next time, get your calculator. Get your calculator. You can come on your calculator. You say 13 to the power 2. It will give you 169. Or you can say 13 times a 13 to give you a 169. Okay, let's continue. So we now have a 169 there. Now, after getting our 169, when you look at the left-hand side, do we have any common factors? Do we have any people who come from the same family? Do we have any letters that come from the same family? Any variables from the same family? Oh, wonderful. You will realize that x squared plus x squared will give us a 2x squared. Remember, it is 1x squared. And you're adding on another 1x squared. You get 2x squared. So we are having a 2x squared. Can you add a 14x to a 49? Of course not. They don't come from the same family. They are not like terms. So we shall remain with our plus a 14x, and then plus a 49, which would equal to 169. Wonderful. Now, remember, after getting that, this 169 on the right-hand side, we are going to pick it and also transfer it to the left-hand side. But remember, it is a positive. The moment it crosses the equal sign, it is going to change the sign and it becomes a negative. How do we do that? This is how we do it. We have 2x squared plus a 14x plus a 49. Now the 169, which is positive, crosses to become a negative 169, which would equal to, now, On the right-hand side, we only had 169. It has crossed. The moment it crosses, no one else remains there, implying that if no one else has remained there, we put there a 0. We have remained with a 0. No one has remained there. So in our next step, Mr. Examiner, sir, we are going to have to also work out the 49 minus the 169. If you're not sure, like I told you, use your calculator. Now, we are looking at 49 minus 169. Some people might not be understanding what I mean by minus. I'm meaning to take away, to remove. 49, remove 169. I remain with negative 120. Good. Now, in our next step, Mr. Examiner, sir, we are having 2x squared plus a 14x. Remember, 49 minus 169 has given us negative 120. A negative 120, which is equivalent to a 0. Now, after getting that, look at what you have. What kind of equation are we having? We are having 2x squared plus 14x minus 120 equaling to a 0. Remember, our teachers taught us something in class. Something in the form of ax squared plus bx plus c equaling to 0. What kind of equations are those? Someone is talking about a linear equation. No, this is not a linear equation. Oh, these are not linear equations. Someone is talking about a simultaneous equation. No, it is not. These are not simultaneous equations. Very good. Someone has told us quadratic equations. So these categories of equations come from the family of equations that we call quadratic equations. Remember, it was a Greek word meaning to square, to a power 2. Now, if it is a quadratic equation, there are different methods that we can use to solve a quadratic equation. We can either use the factoring method or factorization. Another one, someone is talking about the graphical method. Wonderful. Someone again is also talking about what we call the bulldozer. Yes. Another one is talking about completing squares. Those are the 4 methods that we can use to solve a quadratic equation. But now we are going to use the simplest approach. But before we use that simplest approach, remember, in a 2x squared, there is a 2 and an x squared. In a 14x, we have a 14 and an x. But again, in a 14, there is a 2 and a 7. When we come to a 120, there is again a 2 and a 60, implying that we have a common factor here. And our common factor is a what? A 2, which means we are going to break it down. We reduce it into a simpler form to be solved. Now, we can say divide by 2, divide by 2, divide by 2. So that we have 2x squared divided by 2 to give us x squared, plus 14x divided by 2 to give us a 7x, minus 120 divided by 2 to give us a 60, which would equal to a 0. Now, if this is our simpler quadratic equation, we need to factorize it by looking for what we call the factors of the quadratic equation, or by looking for what we call the roots of a quadratic equation. Now, in getting the roots of a quadratic equation, we are going to think of 2 numbers, which when we multiply, we get negative 60. But when we add those 2 numbers, we get a positive 7. I don't want us to use cram work. I don't want us to use guesswork. We are going to use a format here called trial and error. So, viewers, like I was telling you, we made this equation here become smaller because we had a common factor throughout, which was a 2. But someone has reminded me, we didn't divide here by 2, divide here also by 2, because after all, a 0 divided by 2 gives us a what? A 0. We are dividing 0 by 2. Now, we need the roots of the quadratic equation. We need the factors of the quadratic equation. Very good. Now, Mr. Examiner, sir, we need the roots. What are those 2 numbers which when we multiply, we get negative 60? when we add those two numbers, we get a positive 7. What are they? Someone is telling me 10 and 60. I don't know. I'm not sure. Someone is saying 15 and 2. No, let's go and try it together and we see what we get as the answer. Now, Mr. Examiner, sir, let us first go for some side work. We are going to use a factoring method, a breakdown. We are going to decompose. We are going to pick our 60. Alternatively, you can say negative 60. But let us pick our 60. We have it there. We divide by 2 to give us a 30. We divide by 2 to give us a 15. We divide by a 2 again. No, not a 2. A 3. Good. By 3, we get a 6. Someone is saying 6. No, we don't get a 6. 15 divided by 3, we get a what? A 5. Good. Then by 5, we get a what? A 1. The moment you get our last answer as a 1, you stop there. Now we are having 1, 2, 3, 4, 5 numbers. But our interest is not 5 numbers. Our interest is only 2 numbers. We want only 2 numbers, which when we multiply, we get negative 60. When we add those 2 numbers, we get a positive 7. But now here we have 5 numbers. Remember, we are going to use the format of try and error. We see which ones can best suit to be called our roots. Now let us start. If we are to start, let us start by having a 2 alone. A 2 alone. Then we are going to multiply the remaining factors to become one number. That is a 2 times a 3 to give us a 6. A 6 times a 5 to give us a 30. A 30 times a 1 to still give us a what? A 30. So we can say times 30. Now let me ask you, students, when you have a 2 and a 30, when you multiply a 2 and a 30, is there a possibility of getting a negative 60? Yes. When a 2 is a negative, it's okay. When a 30 is a negative, you can still get a negative 60. But is there a possibility of adding these 2 numbers and you end up with a positive 7? No. Even if a 2 was a negative, even if a 30 was a negative, no, it cannot give you a positive 7. So which implies a 2 and a 30 as our roots cannot work. Now, since 2 came out alone, let us now have the 2 and the 2 to give us one factor. That is a 2 times a 2, which is a 4. Then the 3 and a 5 and a 1, we also multiply them to get one factor. That is 3 times 5, a 15. 15 times 1 to still leave us with a 15. Now, viewers, let me still ask you. Is there a possibility of multiplying a 4 and a 15 to give us a negative 60? Yeah, someone is telling us yes, possibly when a 4 is a negative or when even the 15 is a negative. That one is okay. But is there a possibility of adding a 4 and a 15 to give us a positive 7? Mr. Obonyo, no. Even if 4 was a negative, no. Even if a 15 was a negative, no. I think it cannot work. So, which means these 2 roots can still not work. I can hear someone saying that this is a vague question. It is not a vague question. We have to continue and get the roots. Now we are going to add on also a 3. So that we have a 2 times a 2 times a 3. 2 times 2 to give us a 4. 4 times 3 to give us a 12. Now, the 5 and the 1, we multiply them to also give us a what? A 5. Now, viewers, is there a possibility of multiplying 12 and 5 and you get a negative 60? Well, someone is saying when 12 is a negative. Yeah, it's okay. Or when a 5 is also a negative. Yeah, it's okay. But is there a possibility of of adding 12 and a 5 and you get a positive 7? Let us try it out. When a 12 is a negative, we say negative 12 plus 5. You end up with a negative 7. But is that what we want? No. This is a positive 7. No, let's remove the negative and we put it on the 5. The 12 remains as a positive, the 5 becomes a negative. 12 plus negative 5. Do you get a 7? Oh yeah, you get a 7. You get a 7. Yes, you get a 7, which means 12 times negative 5, you get a negative 60. 12 plus negative 5, you get a positive 7. Wonderful. These are our roots. So we can now copy these roots. We bring them here. A 12 and a negative 5. Feel free. Even if you started with a negative 5 and then end with a positive 12, no problem. Now, Mr. Examiner, sir, remember we are factorizing. We are factorizing the quadratic equation x squared plus 7x minus 60. Now, where we have a positive 7x, we are going to pull it out or cut it out or make a replacement with a 12 and a negative 5. How do we do that? We are going to say x squared plus the first root, which is a 12x, plus the next root, which is a negative 5x, and then the last number, which was a negative 60, which is all equated to a 0. Now we are having 4 terms, 1, 2, 3, 4, and we are going to pair them 2, 2 in each bracket. 2, 2 in each bracket. Now we are going to have the first 2 in the same bracket, the next 2 in also the same bracket. Now we are going to look for what we call the common factors. What do you see here as well as there? Remember, in x squared, we are having x times x. In a 12x, we are having a 12 times x. Which one appears here as well as there? Wonderful. Someone has told us it is an x. So we are going to get that x, which is the common factor. We bring it outside the bracket. X into, but remember, there were 2 x's here. One of them has come out. How many do we remain with? Wonderful. We remain with 1x. Plus, we had a 12 and an x. The x is outside. What do we remain with? No, someone is telling me an x, not an x. The x has moved outside the bracket. What do you remain with? A 12. Wonderful. So we have a positive 12 there. Now, we are having a negative 5x and a negative 60. We are looking for the common factors. But remember, there's already a negative here and a negative there. Very simple. That is already a common factor. It comes outside the bracket. Now, between 5x and 60, we also want to get the common factor. Remember, in getting 5 and x or 5x, we multiply a 5 times an x, which means we have a 5 and an x there. But in a 60, what do we multiply to get the 60? We multiply a 12 and a 5, which means here we have a 12 and a 5. But here we have a 5 and an x. What is the common factor? Very good. So we have a 5. Aha. So our 5 will come outside the bracket, Mr. Examiner, sir, into. Here we remain with x. Remember, the negative is out. The positive 5 is also out. We remain with only an x. And here we are getting also the negative x, which came out. But remember, in getting the negative x away from here, the negative from here, we remain with a positive, because a negative times a positive, you get a negative. Now, when you pull out the negative, what do you remain with? You remain with a positive. Aha. In 60, we said there was a 12 and a 5. But the 5 has come outside. What do we remain with? We remain with a 12. Wonderful. Which is equivalent to a 0. We are almost reaching the final answer. Don't get tired. Remember, this is Obonyo Kenneth e-learning project on Google the TV. We are learning O-level mathematics. We started with revision. Now, we are factorizing. We are going to get whoever is outside the bracket. We have them in one common bracket. Or we are going to look for the common factors here. The first common factor here is x plus 12. X plus 12. It appears here and it appears there. So we are going to pick one bracket, which is the common factor. X plus a 12. And then, what do we remain with? The x and the negative 5, which are outside the bracket, which is equivalent to a 0. Now, if the examiner had said factorize completely, we would have ended there. But since the examiner wants us to go ahead and find the value of x, then we can continue and say, Mr. Examiner, sir, either the first bracket which is x plus 12, which is equated to a 0. Or the second bracket, x minus 5 is equivalent to a 0. Now, let us solve the first bracket. We are having x plus 12 equaling to 0. So we shall say x plus 12 minus 12 equaling to 0 minus a 12. So that the 12 and the negative 12 cancel out. We remain with an x equaling to 0 take away 12, 0 subtract 12, 0 minus 12. We remain with our negative 12 as our first value of x. Remember, we are dealing with a quadratic equation. And remember, in quadratic equations, we always get two answers, two values, because of the two roots that we get. Now we are coming to the next answer. X minus 5 equaling to 0. Can someone tell us now how do we move? Wonderful. Someone is saying x, take away 5, plus 5, equaling to 0 plus 5. I know your parents must also be very interested, listening keenly. Yeah, you can ask your parent also to give you one of the answers. I'm sure they'll knock you on the head. Now, negative 5 plus 5. What do you get, students? A 0. They cancel out. You remain with x equaling to, now look here, a 0 plus a 5. Someone is saying 50. Come on, don't spoil our lesson. 0 plus 5, you don't get a 50. 0 plus 5, you are having nothing, plus a 5. Very good. You get a 5. So we get a 5 here as our answer. Now we are having two answers, two values of x. And someone will ask, if we are having two values of x, are we going to use both of them? No, we are not going to use both of them. Remember, we are having a positive answer and a negative answer. But again, remember, when we are dealing with the length, we don't look at negative values. We only look at positive values. So we can tell the examiner, Mr. Examiner, sir, since length cannot be in negatives, we are going to take our answer of x as a 5. You can even write it there. You say, since length cannot be measured, cannot be in negatives. Hence, x is equivalent to what? We are taking the positive value, which is 5 what? Centimeters, which is our value of x. Mr. Examiner, sir, we have found the value of x. Mr. Examiner, sir, we have answered part A. That is what you wanted from us, nothing more. We are now heading to part B. Part B says area of the triangle. And I know someone must be thinking of the formula that we use to find the area of a triangle. I'm hearing someone in the audience saying pi r squared. Come on, this is not a circle. It is only a circle where you use pi r squared. Someone is saying 4 out of 3 pi r cubed. No! It is not 4 over 3 pi r cubed. We need the formula that we use to find the area of the triangle. Someone is telling us length times width. Oh, come on. This is not a rectangle. We are not looking at length times width. We are looking at a triangle. Wonderful. Someone has given us the right answer. Someone has said the area of a triangle is equivalent to a half times the base times the height. Wonderful. This is your base and that is your height. But remember, your base is x centimeters, which x is equivalent to 5, which means we have a 5 here. 5 centimeters. And our height is x plus 7, which is a 5 plus 7. But 5 plus 7 gives us a what? A 12. And here what do we have? A 5. Which means the base is 5 centimeters, the height is 12 centimeters, and the hypotenuse is 13 centimeters. Now we need to substitute and get the final answer without wasting time so that we can rush and sanitize our hands. We need to rush, wash our hands with soap so that we are free from the coronavirus. Wonderful. Now we are having a half times the base, which is a 5, times the height, which is a 12. Wonderful. So, by 2 once. By 2 into 5, not into 5. It cannot be divided. It is into 12. Good. So, by 2, a 6. Now you're having a 6 times a 5 times a 1. But 6 times 5, what do you get? Come on, someone is telling me 65. No, 6 times 5 gives us a 30. And a 30 times a 1 leaves us still with a what? A 30. Now, this will equal to 30 squared centimeters. We are looking for the area of the triangle, and the area, Mr. Examiner, sir, of the triangle is equivalent to 30 squared centimeters. And that becomes our final answer. This has been Obonyo Kenneth, taking you in O-level mathematics on Google the TV, sponsored by the e-learning project. That is the end of our first question, as we try to take some little water and go to question number 2.